right, welcome to another session of Krazifizix Medicine Science Clinic paper review. You have all our information right there on the left side of the screen. Today we want to look at February-March 2018 paper 2 for physical sciences. All right, so again, like we did the last one, and if this is your first video, we're going to run through the paper with you, showing you the different steps, ways to answer questions, multiple choice, structured questions. So in doing all of this, we're doing a whole lot of revision for you. If you need to get to us, 0817442103 is the number to call. 0817442103. We do school classes as well. If you want us to come to your school to help your learners, reach us on the same number. Or as much as possible, just share this video with your learners, give them the link, and let them enjoy a bit of physical sciences, revision classes. All right. So let's run through the paper quickly as fast as we can. We always have a 1 hour mark on every video so that it is easy for learners to transfer from phone to phone and to download if they need to download. So let's go. February-March 2018 Physical Science Paper 2. 1.1. Which one of the following is the general formula of alkynes? Now, these are things you need to know. Okay, quickly. What we do is we run through the whole thing for you again. Alkanes, alkenes, and alkynes. All right, this is Cn, H2n plus 2. Cn, H2n, Cn, H2n minus 2. All right, so it's a difference of two hydrogen atoms. This is saturated, this is unsaturated, this is unsaturated. What do we know about this? This is single bonds, this is double, and this is what? Triple. Quickly. And then that's where we'll stop now on this. So correct answer, CH2n minus 2. My correct answer is C. The type of reaction that takes place when a carboxylic acid and an alcohol react in the presence of an acid. All right, quickly, this is what we do. You know the ACE brand, all right, of Millimil, ACE. Okay, there is no way you can eat the ACE brand without water. And what we do in chemistry is simply now saying alcohols will react with carboxylic acids, all right, to form what? Esters and water. Nice. So anytime you go to the shop and you see the ACE brand, you quickly do your chemistry. All right, and this is called esterification. All right, let's just quickly do something here. Esterification. In the presence of what? Concentrated sulfur, which acts as a catalyst. And this is suitable because it's a dehydrating agent. All right, it's a strong dehydrating agent. So that's a short class there on esterification. So correct answer is D. 1.3. Which one of the following isomers has the lowest boiling point? Lowest boiling point. What you need to do is to quickly check the structure. All right. Since it's an isomer, quickly, since it's an isomer, all right, the quickest thing to say is the more side chains you have, the more side chains you have, the weaker the intermolecular force. The more the side chains you have, the weaker the intermolecular force becomes. So what we need to do is which one has more side chain. Learners, if you go to your structure, time you see things like this, it actually means a side chain. So if you look at this, here, this is a straight chain. All right, look at this one. I've got two side chains here. I've got two side chains on this. So it's going to be a C, a CH3, and a CH3 there. All right, this one again, it's 1, this is 1. So the more the side chains we have, the weaker the intermolecular force, and the lower the boiling point. The lower the boiling point. So my correct answer is B. It's good if you can also try to draw the structures. You would see how these questions are asked and answered. All right, 1.4 now, let's run. 1.4. Which one of the reaction rate versus time graph below best represent the reaction between magnesium and excess dilute hydrochloric acid? All right. Now, one thing about reaction is it starts very, very fast. Is that okay? Reaction between magnesium and excess dilute hydrochloric acid. Okay. All right. Now, this question, you got to be very careful of how you answer this question, because there's going to be a bone of contention between the. All right. Now, which one is more appropriate? The correct answer is C. Why C? The reaction rate is actually going to decrease. All right. We're talking about reaction rate here. All right. It will start very fast and then decrease as time goes on until it ends. Is that okay? So reaction rate will start high and decrease as time goes on. Decrease as time goes on. All right. Look at D. Something quickly to you on D. D actually talks about, the graph of D is correct about maybe product here. And then you have time. The products, you start from 0 and it increases, all right, in how it is formed until the reaction stops, and then you have that. Now that is product versus time, all right? But here we are looking at reaction rate. It starts fast and then decreases as time goes on. All right, good question there. Question 1.5. Which one of the following will not affect equilibrium position? Equilibrium position. This is simply asking you for Le Chatelier's principle. Le Chatelier's principle. What are the factors we know in Le Chatelier's principle? All right, it's concentration, its pressure, and its temperature. These three will affect equilibrium. All right, so the correct answer, which one will not affect? Catalyst, because catalyst affect both the rate of the forward and the reverse reaction. All right, 1.6 now. 1.6. The following equilibrium exists in pure water at 25 degrees Celsius. 2H2O would give us H30 plus OH minus. Now, it's more of acid and base, but linked with equilibrium. Okay, so our focus is more on equilibrium. All right, 2H2O. If you look at it as acid and base, then you might struggle with understanding a few things. But if you look at it as chemical equilibrium, it makes out very, very easy. All right, look at this. Delta H is greater than 0. Now, the temperature is now increased to 90. Now, this is an endothermic reaction. And we know from our content that increase in temperature, increase in temperature favors the endo. Okay, that means if we increase temperature, what happens? The forward reaction is favored. Now, if my forward reaction is favored, what does it mean? If my forward reaction is favored, Means my Kw, which is your Kc, all right? Kw, we have a general way. We have a general way of representing our Kc, and now therefore our Kw now automatically we have this. Now if the forward reaction is favored, what does it mean? It means that I'm going to have more products than reactants. If I have more products than reactant, automatically my Kc value changes. What is my Kc value here? 1 times 10 to the power negative 14. Now my Kc value is going to change automatically. What happens? C cannot be the correct answer. All right, my Kc value would actually change. My Kc value would decrease. But one thing that we know now, if Kc value changes, remember this now as our standard at 25 degrees Celsius. With this, the pH equals to 7 here, and the pOH equals to 7 again. Why? Because the concentration of hydronium ion is equals to concentration of that. All right, I'm trying to get you to the answer now. But if we say this has changed, automatically pH can no longer be 7. All right, so this is also wrong. If pH cannot be 7, then automatically option D is also wrong. Now, because both, look at my reaction. Let's take back to the reactions. All right, here, these are two products. All right, these are two products. We said the forward reaction is favored. It means this and this will both be favored equally. Therefore, my correct option would be that the concentration of hydronium ions is still equal to the concentration of the hydroxide ion. Correct answer is B. All right, that's how we work things out there. So this is more of chemical equilibrium right there. 1.7. 1.7. A hydrochloric acid solution is titrated against an ammonia. All right, if you check one of our videos, we actually listed the strong acids and weak acids. You need to get that video. All right, what do we know? HCl is a strong acid. So I have a strong acid. Ammonium hydroxide is a weak base. That's are the things you even need to look at before you attempt the question. What am I going to form? I am going to form an acidic salt plus water, all right, plus H2O. And this is hydrolysis on its own. When this hydrolyzes, my pH would be less than what? 7. Okay, let's check. Which one of the following gives you pH of the solution at the end point of the, and the reason for the pH? All right, it says pH is 3 because hydronium is formed during the ionization of HCl. pH is 5, hydronium ion formed during the hydrolysis of ammonium, okay, which is similar to what we said here, hydrolysis. pH cannot be 7 because we have a strong acid and a weak base. pH cannot be 9. All right, our correct option is B, because during the hydrolysis of ammonium chloride, check this, NH4Cl, that's the salt, plus H2O, what's going to happen? This lose. And then what do we have? We have NH3 plus Cl plus H30 plus. This alone is acidic, makes the pH less than what? 7. Correct answer is B. Number 8. A decrease in the oxidation number, all right, a decrease in the oxidation number of an atom during a chemical reaction. You need to know that. You need to know that. Go back to, if you check back to the page, go to electrochemistry videos where we dealt with all of this. The correct answer here is reduction. That's definition. A reduction is the decrease in oxidation number. Reduction is decrease in oxidation number. 1.9. The two half reactions below are used to construct a galvanic cell. Which one of the statement below is correct when the cell is in operation? Okay, now look, we have these two values here. One of the things you need to know is that the more positive one, the more positive E cell value or E reduction value will be reduced. So which one has more? X is more positive, so automatically X plus will be reduced. We've answered that already. 1.9 A. That's very simple to answer there. All right. This one here will be oxidized. This is oxidation. All right. Which one of the following is correct for the industrial preparation of sulfuric acid? Sulfuric acid is prepared by contact process, and the correct catalyst is vanadium pentoxide. All right, that's said, done, and dusted. All right, let's run through to our organic chemistry, question number 2. Okay. The letters A to E in the table below represent 6 organic compounds. This is how I like to do my question though, but let's run through all these questions. A tertiary alcohol. First thing, let's go check for an alcohol. It's either C or A. But my correct answer, a tertiary alcohol, let's see. This compound here, that's my functional group. Attached to this carbon atom, all right, only to see. And this carbon atom is attached to 3 alkyl groups. 1, 2, and 3. All right, do you see my demarcation? The OH hydroxyl attached this carbon. That carbon is attached to 1, 2, 3. That is a tertiary alcohol. Correct answer is what? A. Aldehyde. Where is my aldehyde? You need to know your functional groups. When the carbonyl becomes the first carbon, that is my aldehyde. All right, and the correct answer is B. A ketone. Look at the last 3 letters. On. Come back here and check. My correct answer is D. A functional isomer of B. All right. One thing you need to know about isomers, we use cake to quickly talk about isomers, functional isomers. Aldehyde and ketones are functional what? Isomers, as long as they have the same number of carbon atoms. Let's check this. This is butanol. So butanol will be an isomer. It's but 4. So this is aldehyde, and this one here is a ketone. Let's go check. How many carbon atoms? It's but, it's al, it's on. Automatically, my correct answer is D. Aldehydes and ketones are functional isomers, while carboxylic acid and esters are functional what? Isomers. So the next time you see a cake, do your organic chemistry. Write down the IUPAC name of E. Already, guys, we answered that while we were talking there. It is butanol. What about the compound E? IUPAC name of compound E. IUPAC name of compound E. All right, let's go check quickly. What is the longest structure here, the longest chain here? Okay, it's 1, 2, 3, 4, 5, 6, 7. Is that the longest? We just keep checking. 1, 2, 3, 4, 5, 6, 7. Okay, let's check. Is there another one? I see one here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that seems longer now. All right, 8. Let's see. Let's check through. Do you think there could be a longer one? 1, 2, 3, 4, 5, 6, 7. Now, okay. So the longest one here, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, that's my longest chain. Now, if it is 8, what do we know? 8 is oct. Let's put that somewhere. Oct. Now, if you look at this, there is a standing out functional group here, which is an alcohol. All right? So automatically we know this is an alcohol. But let's check something here. If I start from numbering from here, 1, 2, 3, 4, 5, 6. This alcohol is on carbon 6. If I start numbering from here, this alcohol is on carbon 3. The IUPAC says we must start with the one with the lowest number. So it's octane 3 all. Octane 3 all. Between number and a letter we have an hyphen. All right. So let's go check something here. Use a different. This is done. 1, 2, 3, 4, 5. Okay, look at 5. What do I have on 5? 2 carbon is an ethyl group. All right, it's an ethyl group. Okay, now let's look at carbon number. So ethyl is on carbon number 5. Ethyl on carbon number 5. All right, on carbon number 6, what do I have? I have a CH3, which is a methyl. By the way, I have another one here attached to carbon number 6 again. So I have 2 methyl groups on carbon. Now, when you have that, we say dimethyl. So it's 6,6 dimethyl. Now, we need to check alphabetically which one comes first. My E comes before my M. So the name here would be 5. Remember, between a number and a letter, an hyphen. Ethyl, 6, between a number and a number, it's a comma. 6, 6, between a letter and a number again, hyphen. Dimethyl. Okay, let's claim this for space. Dimethyl. Octane 3 all. Right. That's the name there. That is the name of the compound there. That's the name of the compound. I hope we get that. And that's 4 marks. That is 4 marks. You would, for the octane, all right, let's see, you would get a mark for octane 3 all. You'd get a mark for the methyl. You get a mark for the ethyl, all right. And then for the numbering 5 and 6 there, you get another mark. That gives you 4 marks. All right, so please get the rules of numbering very well. All right, let's go on. Define a positional isomer. Define a positional isomer. We need to learn our definitions. Because I still need this diagram, I'm going to use this page. Define positional isomers. All right, these are what? Compounds. Compounds with same what? Molecular formula. I'm just going to write MF here. All right, I'm sure you can write it in full. Molecular formula, but different. Now it's position. So we talk about position. Different position of 1 side chain or functional group on the parent chain. All right, so compounds with the same molecular formula, that's 1 mark, but different positions, because we're talking about positional, of the side chain, the substituents, functional groups. When we say substituents, we mean things like your halogens. All right, these are just substituents. So side chain, substituents, functional group on a parent chain. All right, write down the structural formula of a positional isomer of C. A positional isomer of C. What's C? Butane 1 all. Okay, C is butane 1 all. C is butane 1 all. What do I need? I need an isomer there. Okay, what isomer? Let's go read the question again quickly. What isomer do we need? We need a positional. All right, you'll understand what we mean now. For clarity, let me first draw the original structure. This is the original structure. This is butane 1 all. Butane 1 all. All right. Butane 1 all. I want positional. Now, the position of this is on carbon 1. All I need to do is to shift it to the next carbon. All right. I'm just going to shift it to the next carbon. To shift it quickly. Carbon. Shift it to the next carbon. What we have ourselves butane 2 all. That's a positional isomer. You see, it's 1 here and it's 2 there. Done. All right. The next question says, structural formula of compound D. Look at my D. Butane 2 on. It's a ketone. Compound D. All right. It is actually the same. I'm going to use my B to draw my compound D by moving this into the middle. All right. So I could have this. 1, 2, 3. Now I have this here. All right. It is no longer an aldehyde. It has become a ketone. All right. It has become a ketone now. And what do we have? Butane. Butane, because it is 4 carbon atoms. Carbon 1, carbon 2. That is your butane 2 on there. And that's the structure. All right. Next one quickly. The organic acid. Okay, we're still drawing the structural formula of the organic acid that reacts with compound C. Let me clean all of this. Compound C is butane 1 all. All right, to form butyl propanoate. Okay, butyl propanoate. What do we need to form butyl propanoate? We want to form butyl propanoate. All right, propanoate. What do we need? We need butanol, which is our alcohol. All right, butane 1 all, which we are given here. And we need what? We need propanoic acid. Remember your A's. Propanoic acid. So the question says we must structure propanoic acid. 1, 2, 3. Now, what is the functional group there? It's a COOH. All right. And there we have propanoic acid. All right. Awesome question. And that's the last question on that particular question, and we're done with question 2. So please, organic chemistry is quite very interesting. Get to answer all the questions correctly. Know your functional groups, and you'll be able to deal with things and definitions as well. All right, still on organic chemistry, question 3. Study the vapor pressure versus time graph for 3 organic compounds X, Y, and Z below, which belongs to different homologous series. All right. Atmospheric pressure is 100 kilopascal. Very, very important. Write down the vapor pressure of compound Y at 90 degrees Celsius. Okay, all we need to do here is to come and read our graph. Now, we need to know the calibration. This is 0 and then 25. You need to quickly check. How many boxes do you have? 1. Okay, 1, 2, 3, 4, 5. And the range here is 25. So each box stands for 5. Okay, so let's go check for 90 degrees. 75, 80, 85, 90, 95. You see, it's perfect, 100. So 75, 80, 85, 90. What am I looking for? I am looking for the vapor pressure of Y. Trace it up. We trace it up there. Use a ruler. Okay. And then we trace it there. Perfect. It gives us 50 kilopascal. That's a free 1 mark for every learner. The graphs can be used to determine the boiling point of 3 compounds. All right, what is the defined boiling point? It is the temperature at which the vapor pressure is equal to the atmospheric pressure. All right, temperature where the vapor pressure is equal to the atmospheric pressure. Great stuff. Now, determine the boiling point of compound C. Since we have been able to define, we said the vapor pressure is equal to the atmospheric pressure. And this question, I remember somewhere, let's clean this, that the vapor pressure is 100 kilopascal. Let's go check something here. Vapor pressure is 100 kilopascal. So that's my line. Of compound C, hold on. Of compound X. So let's go check all vapor pressure lines. So here is compound X. It's 5. Remember we said each of those things now is 5. So it's 55 degree what? Celsius. 55 degree Celsius. We're done. Okay. The homologous series to which the 3 compounds of similar molecular masses were identified them as alcohols, carboxylic acid, and ketone. Let's quickly talk about this very fast. We have alcohols, all right, alcohol. Okay, what do we have here? We have carboxylic acids, and then we have ketone. All right, quickly, if we were to identify the intermolecular force in ketones, here we have London, and we have dipole. Okay, we have London and dipole. My dipole exists there. In carboxylic acid, what do I have? I have London, all right. I have dipole. I have dipole. Okay, I have dipole, and I have 2 sites of hydrogen bond. 2 sites of hydrogen bond. What do I have here? I have London. I have dipole, all right, dipole, and I have what? One site of hydrogen bond. One site of hydrogen bond. All right. Which compound X or Y is a carboxylic acid? Number 1, what you need to know? This one is going to have high boiling point, and it's going to have a low what? The lowest vapor pressure. So which one has the lowest vapor pressure in our, because they said which compound is carboxylic, and we're dealing with vapor pressure. So the one with the lowest, can you see it is Z? Z has the lowest, so my answer here is Z. Explain the question to 3.3.1 by referring to the type of intermolecular what? Forces. All right. By referring to the type of intermolecular forces in each compound. Do you see we've already answered our question? Look at what I would say. Carboxylic acid, all right, have London, dipole, and 2 sites of hydrogen bond. Okay, what we normally do to answer this question is we talk about I's. I, to identify the type of intermolecular force. Number 2, compare, so identify your intermolecular force. Number 2, compare the strength of intermolecular force. And number 3, talk about the energy required. Okay, so quite too many stories. We're dealing with just Z. So I would say that carboxylic acids have what? London forces, 2 dipole. So I'm repeating what I just, but you can answer your question like this. And 3, what does it have? It has what? 2 sides of hydrogen bond. 2 sides of hydrogen bond. Okay. Now, what about alcohols? Alcohols also have the same. Have what? 1. So the difference between carboxylic acid and is here. So alcohols, we write the same thing, but alcohols what? Have 1 side of hydrogen bond. All right. Alcohols have 1 side of hydrogen bond. Okay, alcohols have 1 side of hydrogen bond. What about ketones? Already, guys, we answered this question. You just need to rewrite this. Ketones have London and what? Dipole, dipole. So you're talking about comparison. It's a lot of marks. Comparison. So you get a mark each for the comparison of the 3. And then now you talk about you identify, now you talk about comparing. The intermolecular force, okay, please write it in full, of carboxylic acids, we're talking about comparing now, is stronger, or is the strongest. Here we're talking about 3. It's the strongest, all right? And more energy is now required. More energy is needed. Guys, we just write to overcome the intermolecular force. Intermolecular. I hope you get this. So guys, we have 3 types of intermolecular forces, which are London, dipole, dipole, and hydrogen. All right. So London is the weakest, dipole, dipole in the middle, hydrogen bond. Alcohols have 1 side, and carboxylic acids have 2 sides. Remember how you answer. ICE. Identify, compare, and talk about the energy required. 3.3. Compound X. Compound X has 3 carbon atoms per molecule. Write down the IUPAC name. Okay, what do you know about X? X has the highest vapor pressure, which means it has the lowest boiling point. Lowest boiling point, highest vapor pressure, highest vapor pressure. And which one has our highest vapor pressure? It's a ketone. So it's a ketone with a 3. So what should we have there? All right, it's propane. Now let's, to be sure, it's a ketone with a 3. Remember your ketone, it must be now in the middle. So what is this? It's propane 2-on. Or you can simply write 2-propanone. All right, you have your 10 marks there in question number 3, talking about physical properties. All right, question number 4. All right, consider the incomplete equations for reaction 1, 2, 4 below. P, Q, R, and S are organic compounds. All right, we have all of this. Okay, define cracking reaction. Define cracking reaction. Number 1, the word crack means to break down, so that must stay at the back of your mind. All right, cracking. It is a chemical process, okay? It is a chemical process in which longer chain hydrocarbons, this is where the key is, longer chain hydrocarbons are broken down, cracked into what? Shorter chain. So you're just taking them down and breaking them down. Shorter chain hydrocarbons. All right. And one of the kind of cracking is called thermal. When you say thermal, you need a lot of heat. All right. Write down the reaction between number 1, 2, 3, 4 that represents each of the following. A cracking. Okay. Now, if you look at this one, we did a cracking. A cracking must be the opposite. Actually, let's say that it is the reverse of polymerization, but don't define it like that. We just want to explain the reverse of polymerization. So which reaction is polymerization? That looks like a polymerization here. It's 2. But now, if it was a polymerization, okay, you see, 2 is a polymerization, all right? But look at 3. Look at 3. Do you see 3 here? I am breaking down R into 2 components. I am breaking down R into 2 components. So this one is cracking, reaction 3. Cracking. We're breaking down 1 into 2. All right? Addition, reaction. Let's go check. Addition. Addition, we said you must start from unsaturated and you must end in a saturated reaction. If you check our video the last time. All right. If you notice this is a polymerization. Polymerization reaction. N means a number of these. So we add in all of this and we get that. This is polyethene now, all right? So addition reaction there is 2. Addition from unsaturated to saturated. A substitution reaction. You actually start from an alkane to another alkane, to another saturated. Is saturated to a saturated, all right? Which one will it be? Okay, guys, we cannot answer these questions in isolation. I quickly want to show you something here before we go on to answer this question. When you talk about cracking, look at this. We are going to produce an alkane and an alkene. That is quite general. All right. So look at R. We said R produces 2P plus what? Q. Look at my P, reaction 2. NP gives me a polymer. Okay. Automatically, let's try to fix this. This is polyethene. All right, which is made from ethene. Okay, so that means my P is ethene. Automatically, this one is an alkane. Q is an alkane. Hold on, let's go back to reaction 1. Q is an alkane. An alkane plus bromine. This one says 2-bromobutane. Aha! That means Q is not just an alkane, Q is butane. All right, it makes sense now. It makes sense, a lot of sense. All right, so which one is a substitution reaction? It's reaction 1. Because it's an addition, so it's a saturated compound there and also a saturated compound there. All right. One of the conditions now for reaction 1 is substitution reaction. What do you need? One of the general conditions is to talk about heat. Or you can talk about UV light. But if you don't remember that, just use the word heat. All right. 4.3.2. The compound PQRS that represents an unsaturated, guys, we've already answered all of this. Which one is unsaturated? We need either an alkane or an alkene. It's P. Okay. 4.3.3. IUPAC name of P. We answered that. Ethane. The molecular formula of R. Okay, now let's go check. R is 2P plus Q. 2P plus Q. R is 2P. What is my P? 2-ethene plus Q, butane. What do I have? 2C2 here, H4 plus C4, H10. So I'm going to have how many carbon atoms? 4 here, plus another 4, 8. 8 hydrogen atoms plus another 10. This is 10. So what am I going to have? 18. And that's my correct answer. 4.3.5, structural formula of compound Q. Already we said our Q is butane, and I'm sure everyone can now deal with bute. Bute is 4, 1, and it's all saturated. It's all saturated. Saturated hydrocarbon. We have that done there. Structural formula of compound S. Okay, now this is a new one. Compound S. You have 2-bromobutane plus a base here, potassium hydroxide. All right, what are we going to have? Let's draw the structure quickly. 2-bromobutane. 1, 2, 3, 4. All right. 2-bromo. So which means my bromide is on carbon number 2, just like that now. All right. Plus KOH. What are we going to have? All right. Now, I want us to understand something here. When you have 2-bromobutane, all right, we want to find out what's going to happen to this. What will happen to this? We are going to have a reaction here. Number 1, these would break down into K plus and OH minus. When that happens, my bromide is automatically attracted to this. So I'm going to form KBr. All right? Now, I will now need, all right, so I will now need my hydrogen, one hydrogen to react with my hydroxide ion because I have water. Do you see what is formed there? All right, the question is this: which hydrogen atom would I lose? Zaitsev rule now states that we would lose from the carbon atoms with the smallest. All right, remember I have taken this away. So this is out now because that's from this. I will also lose which one now? I will lose this one here. All right, to this to form my H2O. So at the end of the day, what do I have? I have a carbon atom, 1, 2, 3. Remember my hydrogen atoms are still here. I have a carbon atom that is empty. I have that, all right. All right. No, there's a mistake here. This height, I would actually lose this one. I would lose this one. All right. I would lose this one there. So I'm going to have this. Okay, since I'm taking the one from the top, I can have it here, there, and then I have this. Okay, quickly. I'll go back and re-explain now. And that will give me a double bond. What we are saying here is when you talk about a Zaitsev rule, the carbon atom that I'm either losing this or this. The carbon atom that has more, this one is 2, all right, while this one is only what? 1. The carbon atom that has 2 would lose because I need to form what? Water, all right. If it is the Markovnikovs we are adding, all right, we add to the more, and the opposite now is the Zaitsev. The one that has more would what? Lose. So if I were to lose this one becomes what? Empty. I hope that makes sense. All right, so I have 1, 2, 3 there. On this carbon I have 1 hydrogen. On this carbon I have another hydrogen. So this is actually what we have at the beginning. But we now see, because the valency of carbon now is what? 4. So this now has to be completed as 4. And we have the structural formula. So please do not forget that we lose the carbon atom that has more. When you talk about Zaitsev, the carbon atom that has more will lose. Is that okay? Will lose. The carbon atom that has more will lose. All right, and then we have our organic chemistry done there. All right, good stuff. Okay, let's quickly finish question 5 in this session. Let us use the reaction between sodium thiosulfate and hydrochloric acid to investigate one of the factors that affect reaction rate. The balanced reaction is given below. All right, here we have the diagram. In the first experiment, 50 cm cube of sodium thiosulfate solution is added to 100 cubic centimeter of a 2 mole per dm cube dilute hydrochloric acid in a flask that is placed over a cross drawn on a sheet of white paper. The hydrochloric acid is in excess. All right, so this is talking about the rate of reaction. The time taken for the cross to become invisible when viewed is recorded. All right, so we have all of these as our time frame. Define reaction rate. This is a definition that you need to also know. All right, how do we define reaction rate? It is the in concentration of products or reactants per unit time. All right, that's how we define that. It could also talk about amount of moles. It's fine. Okay, how does the concentration of sodium thiosulfate solution used in experiment 2 compare to that of experiment 5? So we're looking at 2 and 5. Let's go check something there. Look at the time it takes in 2, 28,6. Look at the time in 5. All right, and we know that the higher the concentration, the faster the rate of reaction. So 2 is using a shorter time, which means my answer should be more than, because the concentration determines the rate of reaction. So it's more than there, more than. All right, more than. Draw a graph of average reaction rate versus volume of sodium thiosulfate used. All right, so we have a graph page and we need to draw a graph quickly. All right, so in order to make that easy, we've put a graph page there, and let me do something here. I need my values, okay, so that we can draw this graph together and see what to do. Okay, let's use something different, a red ink there. What am I average rate? All right, and I am using that against volume. Okay, they've helped us, it's calibrated. Now what we need to do, let's start from the top one, 50, when volume is 50. So I'm dealing with 50 volume. What is my reaction rate there? It's 4,4. Please, it is important to know quickly what each box stands for. Now, if you notice, the difference here is 0,5. So you say 0,5, then you count the number of boxes, 1, 2, 3, 4, 5. 0,1, which means each box is now 0,1. So if I'm looking for 4,4, what will it be? It's on 50. That's my 4. 4,1, 4,2, 4,3, 4,4. There. Okay. 4,4. Right there. All right. 43,5. All right. 43,5. Okay. I think that's quite easy. 2,6 on 30. 30, so this is 2,5. Remember we said each box stands for 1, so it's 2,6 there. 1,7 for 20, 1,7 for 20. It's 1,5, 1,6, 1,7, 1,7 for 20 there. And the last one, 10 and 0,9. 0,9 is just before 1. All right. And then you can now plot your graph, which is almost a straight line graph, almost a straight line graph there. All right. Okay, I'm using a free hand, so I'm missing those spots just by chance, but your graph should look just something close to that. All right, so please use a ruler. Okay, let me see if I can just get something better to draw my line. All right, okay, there I go. All right, so use the black one, not the red one. And there we go, almost all there. All right. Okay, beautiful. All right, that's the graph there. And you get yourself some free marks just by doing your graph. Now let's quickly answer the remaining section of the question here. Okay. All right, unfortunately, my smart board is frozen again, and that's why I always want to cut this video short. All right, but so we will continue from here in the next session. So look for the part B, which should be the concluding part of this video. We will just start from our rate of reaction and finish up. All right, again, this is Krazifizix, helping you out with physical science. Watch out for our maths videos as well. Quite interesting, quite awesome. Please get to our page, drop us a message, and let us know if this is helping you and what more we can do to give you better video production, better classes, and so that you can pass your matric exam in flying colors. Thank you. See you in the next session.